Hello folks, this is also a question from another board, of course useful for you. So this is concerned with stationary waves actually. So the question says a standing wave is set up on a string, so these are the waves. 2 points P and Q on the string are located as shown. So Q has a slightly higher amplitude than this P because the amplitude is, this is the mean position. So we calculate amplitude from here. So this is a bit more than this. Which row correctly describes the phase difference and the maximum speed of the vibrations of the 2 points? So we have to talk about the phase difference as well as the maximum speed of the 2 points. So regarding phase difference, what we have to remember is, so in a stationary wave, this from here to here it represents the wavelength, full wave, and from here to its half wave. Just to be remembered that when this point is over here, the falling point over here, and so on. So what happens is, when all the points are over here, the points of the opposing half will be somewhat like this, exactly in an opposite scenario. So right now, this point is at its highest amplitude. This point is at its highest amplitude. This point is also as its highest amplitude. This point is also as its highest amplitude, and all the other points are at the highest amplitudes, and all are negative. So that means the phase of all these points is same. All these points is same. Similarly, the phase of all these points are same, but the phase of these points and these points are exactly opposite, because they are at the top of their motion, they are bottom of their motion, they are at the top of their motion. They would now go upward, they'll now go downward, and so on. So these are of same phase, and all these things are of opposite phase compared to this thing. So since they are of same phase, the phase difference should be 0. The phase difference between them should be 0. So that means this choice number A and choice number C, they disqualify. So only B and D qualify. Now regarding the maximum speed, so they are at their maximum amplitude here. At this point, they are at zero position, zero velocity. So when they go there, when they go towards the mean point, the amplitude of this thing is higher. This thing is higher, and this is lesser. So according to our philosophy, so what we have is, the equation is V equal to omega R. Omega is the angular velocity of the wave actually. R is the amplitude. So this amplitude is higher than this amplitude. So that's why the velocity of the wave while passing through the mean position, which is the max velocity, should be higher in case of Q rather than this P. So that's why the max velocity should be different. So that means choice number B should be the correct choice, and D is the incorrect answer. Now if somebody argued that we don't study this in AS, and this is the question of AS, what you can argue is, since it has got high amplitude here, higher amplitude, so when it goes to this point, definitely it must have higher velocity. Similarly, this has even higher velocity, so this has got lower velocity. So as you go towards the highest amplitude, the velocity will be high when it passes through the origin, through the mean point, and as you go from here to here, the velocity as it passes through the mean point should be less. So the velocity should be definitely different for P and Q. So choice number B is the correct answer.